We're going to talk about the quadratic formula and use the quadratic formula in Algebra 1, but just a quick review. Quadratic formula is x equals negative b, or the opposite of b, plus or minus the square root of b squared, minus 4ac all over 2a. And let's get rid of that fraction bar and not make it all the way up. There we go. Okay, and really we have to make sure that our quadratic is in standard form to be able to use this. So that's ax squared plus bx plus c equals 0. Okay, the discriminant is b squared minus 4ac. And the discriminant helps us to determine how many zeros there are. It's that part that's inside the radical there. So if the discriminant were negative, it equals a negative number, meaning it's less than 0, then you would have maybe a graph that would look something like this. It wouldn't cross the x-axis, meaning you'd have two imaginary solutions. The other option you could have is if you had b squared minus 4ac actually equaling 0, then you could possibly have a graph that would look something like this. It would definitely hit the x-axis in one location, and you would have one real solution. And then you could have b squared minus 4ac, your discriminant there. It could be a positive number. And remember, if the inside of that radical is positive, then you're going to have opposite of b plus whatever that root is, and then minus whatever that root is. And that's going to give you two real solutions. And it's going to be a situation where your quadratic can maybe look something like that. You'd intersect there and say there. You'd have two real solutions. Okay, and I should have emphasized this here. If b squared minus 4ac is 0, well, the root of 0 would give you 0. So really you would just be left with negative b plus minus 0. So it would just be negative b, or opposite of b, over 2a. That would be your one real solution there. And then if it were negative, well, you'd have a root of a negative. So you'd have opposite of b plus or minus the square root of a negative, which would you'd pull that negative one out, and it'd give you two imaginary solutions. So we use the discriminant to help us determine how many possible solutions there are. And it's just a value here. So if we're trying to find the discriminant, it just comes up to be a value, and we determine if it's negative, 0, or positive. I'll show you how we do that here in a few minutes. All right, so solve each equation using the quadratic formula. Okay, and so remember, before we can use the quadratic formula, we have to put it in the form of ax squared plus bx plus c, okay, equals 0. And it's always nice to just have the quadratic formula written out, so I'm going to go ahead and write it out here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so if you have that written out, and you know you need to get in this form, I'm going to start by moving the 6x over by subtracting it over. When I say over, I mean over the equal sign. And then moving that 3 over as well by adding it over. That's going to equal 0. Okay, and so that tells me that a in this problem is 3, b is negative 6, and c is 3. And it's nice just to have what a, b, and c are. That way you can easily plug things in. So we have x is equal to the opposite of b, to the opposite of negative 6, plus or minus the square root of b squared. So negative 6 squared minus 4 times a times c all over 2 times a. All right. And so that is going to equal negative negative is positive, so we get 6 plus minus. Negative 6 squared is 36 minus 4 times 3 times 3. In this case, well, negative 4 times positive 3 times positive 3 is negative. And, oops, sorry about that. That's going to give me negative 36 all over 2 times 3, which is 6. And so we get 6 plus minus, well, 36 and minus 36 is 0, so we get the root of 0 over 6. And notice root 0 is just going to cancel that out, so I'm just going to be left with 6 over 6. Okay, this part's just going to disappear, and the plus minus is then gone, which means x equals 1. Now remember, this is what x equals. Okay, we'll kind of bring that down. X equals 1. All right, well, if x equals 1, we've now found that one solution. Okay, so this would be one of those situations where the graph would come down. It would hit at 1 on the x-axis. Okay, so we'd do something like, maybe like this. Jump back up. Okay. In fact, I know this is 3 here. This has nothing to do with what we're doing here, but that's the y-intercept, right? Y-intercept is 3. It's when x is 0. So there's 1. Okay, that's from that one right there. All right, so my solution is 1. Notice the discriminant value would have been 0, which would have told us that the solution was 1. Remember, if our discriminant is 0, that's where we get that one real solution. All right, so we're going to try a different one here, and I'm going to go ahead and switch colors. So we're going to, so again, I'm going to move this over and this over. Okay, so I'm going to add that 3x, so I'm going to have x squared plus 3x minus 40. So move that 3x and move that 40 over equals 0. So in this case, a is going to be 1, b is going to be 3, and c is going to be negative 40. All right, and then we'll go ahead and just go ahead and do x is equal to negative b, so negative 3, or the opposite of b, plus or minus b squared, which is 3 squared, minus 4 times 1 times negative 40, all over 2 times 1. So we get negative 3 plus minus square root of 9, and then negative times 1 times negative. Notice this piece right here, that's a negative times positive times negative is going to be plus now. It's going to be plus 160. All over 2 times 1, which is 2. So we get negative 3 plus minus the root of 169 over 2, which is equal to negative 3 plus minus 13 over 2. So from here, you really have two problems. You have negative 3 plus 13 divided by 2, and negative 3 minus 13 divided by 2. So that is 10 over 2, also known as 5. And this one is negative 16 over 2, also known as negative 8. So my solutions here, x equals negative 8, and it equals 5. So this would be one of those situations where you'd have a graph, say something like this, where it crosses the x-axis in 2 locations. Okay, so maybe this right here is negative 8, and this right here is 5. Probably not the best scale because our y-intercept would have to be negative 40, and that's that would be a tough thing to buy there, but that's okay. The solution's negative 8 and 5. All right, we'll switch colors one more time. Go green on this one. I think it's green. Okay, and I'm going to go ahead and add that 5 over to that side. Okay, so it's going to give me 8x squared plus 6x plus 5 equals 0. And then I want to go ahead and identify A, B, and C. So in this case, A is going to be 8, B is going to be 6, and C is going to be 5. All right, and so all right, so we will have the opposite of B, so -6 plus or minus square root of B squared, so 6 squared is 36, minus 4 times A times C. Okay, so I condensed a few steps there, all over 2A. So notice I just put in -6 because that was +6, and I squared the -6 to give me +36. This part is always going to be positive, and it's easy to just write in what the opposite of that number is. Okay, and so we get -6 plus minus. Well, that is the square root of 36 minus 4 times 8 times 5, which is 160 all over 16. Now that's going to give me -6 plus minus. Notice I get a negative in there, -124. Okay, all over 16, which means I have imaginary solutions here. Okay, so it's going to give me -6 plus minus. I'm going to break this up. That root I'm going to break up into root -1 and root 124 over 16. And some of you recognize right away that that root 124 has a perfect square that goes into it. So root -1 is going to become I. Root 124 is going to break up, and we're going to break that up into root 4 by 31. Okay, so this becomes this piece right here. All right, and then this became this piece right here. We'll go all over 16. All right, so that now is -6 plus minus, well, that's 2i, square root of 4 is 2i, and then we keep the root of 13, or 31, excuse me, all over 16. All right, well, that right there would be fine, except for you could take a 2 out of 16, out of 6, and out of 2. So this would have to be rewritten as, you know what, I've ran out of room, so I'm going to have to kind of improvise here a little. I'm going to have to write it right here. I'm going to rewrite that as 3 plus 1i root 31 over 8. And that is our solution. All right, so two imaginary solutions. We actually simplified the radical there. And oops, and you know what? I dropped that negative, so I better put that negative back in. That's a -3 because that was a -6. All right, very good. So we have an example here of one solution, two solutions, and of no real solutions, but two imaginary solutions. Okay, find the discriminant of each equation, and then state the number and types of solutions. Okay, so the first thing you have to get it into, once again, you know, every time I hit that today, it does that. So you want to think, well, it's got to be ax squared plus bx plus c equals 0. And then we want to think, well, the discriminant is b squared minus 4ac. Okay, that's what our discriminant is. All right, so as I'm looking at this and trying to complete this, I'm going to go ahead and move that -10 over to that side. Okay, and so that's going to give me 9x squared minus 3x minus 8 plus 10 is plus 2 equals 0. All right, and then if I think, well, ABC, A equals 9, B equals -3, C equals 2. So B squared minus 4AC, that's the discriminant. That gives me B squared minus 4 times A times C. So -3 squared, 4 times 9 times 2, or 9 minus 36 times 2, or 72, which is -63. So the value of the discriminant is -63, and since it's negative, that means there are two imaginary solutions. All right, which means it never crosses the x-axis. Okay, let's try a different one here. Let's go with this one. We're going to move that -6 over. Okay, so we're going to get -2x squared minus 8x, and we're adding 6, so it's -14 plus 6, or minus 8 equals 0. Okay, and so A, oops, didn't want to do that, so let me erase that A, and get back to the correct page, and write what A actually is. So in this problem, A equals -2, B equals -8, and C equals -8. All right, a lot of 8s there. All right, so we have B squared minus 4 times A times C, or -8 squared minus 4 times -2 times -8, which is 64 minus, well, we have a negative is a negative, so it is going to be minus, and 4 times 2 times 8 is 64, which is 0. So the value of our discriminant is 0. And if the value is 0, remember that means you have one real solution. That's because if we were using that quadratic formula, remember the quadratic formula, x equals opposite b plus or minus square root of b squared minus 4ac over 2a. If we were to look at just this piece and we get 0 for this piece, that would say opposite of b plus or minus the root of 0, which means this chunk would be completely wiped out. And we just have one answer, -b over 2a. Okay? And so that's what we're thinking of when we do that. All right. Let's go back to that. Okay. So let's try one more. In this case, I'm going to move that 8x over again. So -7x squared. And this, well, now I have 16 minus 8x, which is plus 8x. And that's equal to 0. And so when I list my A, B, and C on this one, A equals -7. B equals 8. Well, C, notice there's nothing back here, so it would be like having a plus 0 right there. So C equals 0. So when I do B squared minus 4AC on this one, notice what happens. 4 times A times C. Well, that B is here, so we get that 8 squared, and we have 4 times -7, but then C is 0. So I'm multiplying this chunk. 4 times 7 times 0 is 0. So I just get 64 from the 8 squared plus 0, which is 64. That's the value of my discriminant. And since it's positive, I have two real solutions. All right, and that would mean if it would be opposite of b plus or minus the root of a positive, so I'd have to do the plus and the minus piece. All right, one more thing, and if you're in Algebra 2, you're going to use this. If you're doing Algebra 1 and reviewing the quadratic formula, you probably could skip this part right now, but when an object is launched or thrown to the formula, the formula used, I think that's supposed to say used right there. Well, I'd actually have to get to that page there. Oh my gosh. Let's try it here. Let's change this to used. The formula used to relate height as a function of time is h equals negative 16t squared plus v sub 0 times t plus h sub 0. V sub 0 means that's your velocity. And it's an initial velocity. And initial means your beginning velocity. Okay? And h sub 0 is your initial height. Anytime you see something sub-zero, that's generally what you're talking about. It's an initial amount, initial height. And then t, just so you know, should define all these, stands for time. And we're going to go time in seconds here. Okay. So your velocity can be positive, just so that we're aware this says plus, but it could be minus also. So it's positive if whatever you are launching or throwing is thrown upward. So if an item is being launched or thrown upward, say like so, okay, V is positive. If an item is being launched or thrown downward, V would be negative. And if your item is being launched or thrown parallel to the surface, that didn't look too parallel to the surface if we're just using our computer there. But if it's launched or thrown parallel to the surface, or for that matter, if it's just dropped without any force, without any added force, then it's got a zero velocity, which just means you'd have negative 16. So like in this one, you'd have h equals negative 16 t squared plus h sub 0. The v part would be gone because you'd have 0 v. Okay, so this would be, all right, that's becoming frustrating. All right, so this would become positive v sub 0. This over here would be negative v sub 0, and this would be 0 v sub 0, 0 times v sub 0, which would just be 0. All right, so with that being said, I'm going to go ahead and work some of these out here. Get rid of that. All right, an archer shoots an arrow into the air. The arrow leaves the archer's bow 5 feet above ground, has an initial velocity of 60 feet per second. The arrow hits its target at a height of 3 feet. How long is the arrow in the air? Okay, so if we're using our formula, h equals negative 16 t squared plus v sub 0 times t plus h sub 0. Okay, and we plug in what we know. The arrow leaves the archer's feet 5 feet above, or leaves it the archer's bow 5 feet above ground. That means our initial height is 5. This is our h of 0, or h sub 0, and has an initial velocity of 60 feet per second. Since it's going upward, it's a positive velocity, so this is our v sub 0. And so we'd have plus 60 times t. And then this is still negative 16 t squared. And the arrow hits its target at a height 3 feet, a height of 3 feet. So that means its height is going to be 3 feet of the target. And now if I solve this, I'd subtract the 3 feet over, And I'd end up with 0 equals negative 16t squared plus 60t plus 2. And then from there, well, I want to find out when it's going, how long is the arrow in the air? Well, we're going to solve for t. A equals B equals and C equals, so A equals negative 16, B equals 60, and C equals 2. And so I think I'll use the quadratic formula here. So we'll say, in this case, I'm going to start it here. So I have actually let's just start it over here. So we'll have T is equal to the opposite of B, plus or minus square root of B squared, minus 4AC, all over 2A. And that's going to be the opposite of B, which is negative 60, plus or minus, and that's a 60 minus 66. 60 squared, which is 3600, minus 4 times A, negative 16 times C, 2, all over 2 times negative 16. And so this is going to give me negative 60 plus or minus the root of 3600, and 4 times negative 16 times 2 is 128, all over negative 32, which is negative 60 plus minus 3728 over negative 32. And now when I actually do some calculations there, this is going to break into 2 different parts. Remember, this is going to be negative 60 plus minus, or plus, excuse me, plus my root of 3728 over negative 32. And this one's going to be my negative 60 minus the root of 3728 over negative 32. And so if we kind of keep working this way, that's going to end up giving me, well, let's go an approximation here. If we actually plug it into our calculator, we get negative 0.03 to the nearest hundredth there. And this one gives us an approximation, let's see, 3.78. Now, this is in terms of seconds. Okay, so this is saying negative 0.03 seconds. Well, your time can't be negative, so that one's not going to work. 3.78 seconds looks like is our winner. And that means it's going to take 3.78, or the arrow's in the air for 3.78 seconds. All right, well, that's all there is. Well, good luck.